Launched on October 19, 2008, the Interstellar Boundary Explorer, or IBEX spacecraft, is unique in NASA's heliophysics fleet. IBEX looks at the very edge of the sun's reach, starting at about 8 billion miles away. The region begins with the termination shock and ends with the heliopause. Between those two is the heliosheath, a teardrop-shaped region sculpted by the pressure of the interstellar medium. IBEX is also different because it makes its images from particles instead of light. Over the course of 6 months and many orbits, IBEX can paint a picture of the entire sky in energetic neutral atoms, or ENAs for short. During its first 5 years, IBEX has made some astounding discoveries.
The IBEX mission science team has used data from the spacecraft to construct the first ever all-sky map of the interactions occurring at the edge of the solar system, where the sun's influence diminishes and interacts with the interstellar medium. The most startling finding as a result of this map is a bright ribbon of energetic neutral atoms emanating toward the sun from the edge of the solar system.
New data from NASA's Interstellar Boundary Explorer reveal that conditions at the edge of our solar system may be much more dynamic than previously thought. This second set of all-sky maps show the evolution of the interstellar boundary region. The mysterious ribbon feature at the nose of the heliosphere has changed shape, and a knot-like feature has formed. This variation over time is forcing scientists to try to understand how the heliosphere can be changing so rapidly.
Because IBEX is orbiting Earth, it also can observe the creation of energetic neutral atoms along the nose of Earth's magnetosphere. ENAs are created there as solar wind protons take electrons from hydrogen atoms in the outermost vestiges of our atmosphere, known as the exosphere. IBEX has also scanned another nearby world with surprising results. The Moon has no atmosphere or magnetosphere, so the solar wind slams unimpeded into its surface. About 10% of the impinging solar wind protons bounce off the lunar surface, becoming ENAs as they do.
IBEX has now made the first direct measurements of hydrogen, oxygen, and neon from outside the solar system. The measurement of these atoms has enabled scientists to get a better grasp on the environment around our solar system. The speed of the galactic wind registered around 52,000 miles per hour. Heavy interstellar atoms show a difference from the solar system and galaxy as a whole. This puzzle may mean that the sun has moved out of the region where it formed, or that some of the oxygen has been captured by dust in interstellar space.
New measurements by IBEX have suggested that there is no bow shock to the heliosphere. The previous understanding of the boundary of the heliosphere was that outside the influence of the sun, a shock wave was formed by the entire heliosphere pushing through the interstellar material around it.
IBEX recently mapped the boundaries of the solar system's tail, called the heliotail. If we could look straight down the tail, we would see a shape a little like a four-leaf clover. The two side leaves are filled with slow-moving particles, and the upper and lower leaves with fast ones. The entire shape is rotated slightly. This indicates that as it moves farther away from the sun's magnetic influence, the charged particles have begun to be pulled into a new orientation, aligning with the magnetic field of the local galaxy.
Recent measurements of the interstellar wind by IBEX have shown that its direction has changed by about 7 degrees in only the last 40 years. While the cause of this shift is unknown, it may be telling us something about the changing conditions as we move through the Milky Way.
As IBEX continues to scan the edge of the sun's influence, who knows what other discoveries it will make?